Hello class, here is a presentation on function intro. Okay, these are the keywords, some of the keywords that you need to be familiar with when it comes to function or topic that is related to functions. So we are going to cover some of them here, uh, but uh, on this topic, these are the some of the words we'll be using. Okay, such those words include set, relations, mapping, domain, range, input, output, x coordinate, y coordinate, equation, function, function notation, one-to-one, function, and vertical line test. Okay, so there are more, but this will get you started. So, what is a set? A set is a collection of distinct objects called element, often shown in braces. Okay, what we call braces are these right here. So uh, all these are example of sets. A, B, C, D are example of sets. Okay, so now you can see that some of the element, okay, are this way. That means they are individual element written uh, this way. They can be they don't just have to be numbers. That can be alphabet, characters, symbols, as long as they are distinct. Or they can even be order pair. Okay, we are going to talk about order pair later on. Okay, but C and D are set of order pairs. Okay, okay, where you have an input and an output. So each element is written that way. So now let's talk about a relation. A relation is a set of order pair. So this means that C and D are what we'll call a relation. Okay, because it's they are both sets of order pairs. Okay. Now, when we talk about order pair, we are talking about element of a set that are written this way, where you have an input and an output. The first element is okay the input value. So 2 is the input value right here, and 7 is the output. 4 is the input value right here, and 9 is the output. Okay, so the reason why these are called order pair, it's because order matters. Okay, for example, writing 2 7, and that would be different than, for example, if I were to say 7 2, that's a completely different order pair if I write this. So 4 9 is not the same as 9 4. Okay. Um, so uh, make sure that when you are writing an order pair, you write exactly what you mean. Okay. The input first, the output first, the x value first, the y value second. Okay. Now, there are several ways that you can represent a relation. Okay, it can be represented using equations, table, mapping, or a graph. Okay, you might be familiar with equations already. Okay, so here are two examples of a relation that are written as equation: y equal 2x and p equal 8t plus 5. Okay, you can write a relation also using tables. Okay, and as you see right here, you have your x value here. Remember, your x value are your input values, and your y values are your output values. For uh, here we have, okay, x equal 3. Okay, the input 3 give you 7. Okay, the input 5 goes to 9. Input 8 goes to 8, and input 9 goes to 13. Okay, so and so forth. Okay, and you can see uh, if we wanted to write these are order pairs, we can. Okay, so the order pair 3, 7, for example, we can write that. If we are talking about this order pair, we could write 3, 7. Okay, and that will represent this order pair right here. Okay, right here. Okay, the 3 represent the x value, and the 7 represent the y value. Okay, so all these are example of relations. Okay, using tables. We can represent a relation also uh, using mapping. Okay, so uh, here is the domain element. Okay, and the range element. Okay, and you can see, so, and A goes to 1, B goes to 2, C goes to 3, and D goes to 4. Okay, and there's nothing that goes to 5. Okay, right here we have 2 that goes to 7, 3 goes to 8, and 3 also goes to 12. Okay, 4 goes to 14. So these type of diagrams are called mapping diagrams. Okay, finally, okay, we can use graph to represent relations. Okay, and so here is a relation. Okay, uh, and remember when we are using graph, okay, the vertical axis is the y coordinate or the y axis, and the horizontal axis is the x axis or the x coordinate. Okay, so yeah, a few more relations that are graphed right here. Okay, on the coordinate plan. Now let's talk about functions. Okay, a function is a relation, okay, in which each input has exactly, this word exactly is very important to the definition of what a function is. Okay, exactly. Okay, that's a very, very important word. Um, so a function is a relation, okay, in which each input has exactly one output. Okay, this can be proven by the vertical line test when the relation is graphed. Okay, we need to use some example to illustrate this. Now, so let's go a little bit up here so that we can see, okay, the relations that are functions. Remember, not all relations are functions. A relation, again, is a set of order pair. Now, so since these relation in green are not set of order pairs, they cannot be functions. Okay, so since this set right here are not order pair, they are not relations. Okay, so the blue one are relation because they are set of order pair. Now let's see if any of these relation in blue are functions. Okay, to see if they are function, we say that to every input at the first element, okay, we want to have exactly one output. So 1 goes to 2, okay, 4 goes to 8, and 7 goes to 10. So this, yes, this would be a function, okay, because every input has only one output. 1 only goes to 2 and nothing else. 4 goes only to 8 and nothing else. 7 goes only to 10 and nothing else. So this relation right here is a function. Is this one a function? Let's check. 2 goes to 7, 4 goes to 9. We have an issue right here. Okay, we have 2 that goes to 7, and we also have 2 that goes to 4. Therefore, this one is not a function. Okay, because okay, to be a function, every input need to have exactly one output. We have 2, that is an input right here that has 7 as an output, and we also have 2, the same 2 has 4 as an output. So anytime that you have your input that is repeated, okay, with a different output, that's not a function. So this one, D, is not a function. Okay, now let's check further. Of course, when a relation is written as an equation this way, it's a function. Okay, you can double check. Uh, your input are x values. Okay, and you can see that for every x that you are going to plug in, you are going to find a different y value, same as t. Okay, so both of these equations represent functions. Okay, now let's look at these relations and see if any of them represent a function. Now, one easy way to decide if it's a function is for you to look, okay, to see if the input is repeated. Okay, I see 3, 5, 8, 9. I don't see any in the same input repeated twice in any of them. So that means this one is a function. That's okay. Okay, because every input has exactly one output. Each one of them, each one of these has exactly one output. Okay, so this is good. This is a function. So yes, this is a function. How about this one? 1 goes to 4, 2 goes to 5, 3 goes to 4, 6 goes to 8. Now, uh, notice the requirement for it to be a function is that each one of these has exactly one of these. Okay. So the fact that the 4 is repeated, that's not a big deal. Okay. Um, so if we had an element in the input, okay, the same element that we're going to 2 different output, then that would be a big deal. So this also, despite the fact that 4 is repeated, is a function. Okay. Now, how about this one? Is this a function? Uh, okay. 2 goes to 4, 3 goes to 8, 5 goes to 7, or 2 again goes to 6. So this is not a function because of this 2 right here. Okay. Remember, each input need to have exactly one output. We have the same input 2, okay, that has 2 different output. so that's not a function. Okay, so the input element, okay, anytime that you see the input repeated in a table, okay, or in any set, the input element repeated, okay, with a different output, that's not a function. So this is not a function. Okay, hopefully that give you enough example to see what is a function and what is not. Okay, here is the situation of a relationship. Is this a function? Let's check. Every input has exactly one output. A go to 1, B to 2, C to 3, D to 4. The fact that nothing is going to 5 is not a big deal. Okay, that so this one, yes, is a function because every input has exactly one output. Okay, so that make that this a function. So this one is a function. How about this one? The answer is no, not a function. Why? Okay, I'm looking right here. I can see that 3 has two different output. Okay, that means 3 is going to 8. At the same time, 3 is going to 12. Okay, so that's right away tell me that this is not a function because uh, this input has two different output. It does not have exactly one output. So that's how you distinguish. Okay, one trick that I tell students to help them identify if something is a function or not is to think of the domain element as the student in the classroom and the range element as the home they are going to. Okay, so uh, if a student, okay, cannot be in two different home at the same time, okay, so if you have that situation that a person can be at two different places at the same time, then you'll know that that's not a function. Okay, and if you go a little bit at the top, okay, we'll see that okay, the same person, if we call to a person, okay, is at a place name 4, and the same person also is at a place name 6. Okay, so that's why this is not a function. Of course, I'm using an analogy. I'm not using mathematics. I'm trying to give you some tips so that you can remember and make the difference. Okay, now this one, we said that this one is a function despite the fact that the 4 is repeated because the difference here is that this person goes to this place, okay, and this person also is at the same place. So these are different people that are uh, going to the same place, that are the same place. That's a possibility, okay. What is not possible is this case right here, that the same person is going to is present in two different places at the same time. Okay, so this is okay. This is not okay for functions. Okay, so this is not a function. Okay, for the same reason, this one is not a function. Okay, because we are following the definition of what is a function. Um, where is the definition right here? Each input has to have exactly one output. Okay, so what if you have a relation that are represented as graph? How do you know which one is a function? Okay, now remember your input are your x values and your output are your y value. Okay, if I were to every x value right here, okay, if I were to find the corresponding y value, do I always have one and one only one odd value, a y value for every x value? For this one, yes. Okay. For this one as well. Okay. Every x value will have only one odd value, one y value. Every x value will only have one y value. How about this one? Okay. We know that's not a part. This will not be a function because we can see an x value that is right here will have a y value right here and also another y value right here. Okay. So we can see that for any x value right here, we have two different y values. So this one is not a function. Okay. So this one is no, not a function. Okay. This one, yes. This one, yes. Okay. And there's a test. If you have a graph, there is a test that we use called the vertical line test uh, to show if something is a function. The way that test works is if you trace a vertical line, let's see. Okay. If you trace a vertical line, um, and if at any point of the graph, okay, that vertical line need to pass through the graph. Okay. I think I chose the wrong tool. Okay. That vertical line need to cross the graph only once. Sorry. I think I made cross the graph only once. Okay. Let's clean this up. Okay. I was trying to trace a vertical line, but I think I ended up messing up my drawing. Okay. So let's try again. So trying to find a different. So if I'm tracing a, here is a vertical line. Okay. You see, no matter where I trace that vertical line, it will only cross it my graph only once. I want to choose something like this. Okay. Only cross the graph only once. So and the same thing right here. Okay. Let's see if I can duplicate this. Okay. You see, no matter where I cross it, it only passes once right here. Okay, so this one passed the vertical line test as well because it cut through the graph only once. Okay, anytime that the graph of a relation, okay, passes the vertical line test, okay, that relation is represent a function. Okay, now let's use the vertical line test right here. Okay, okay, and you can clearly see that this one does not pass the vertical line test because okay it cut through the graph uh, more than once, so that's not a function, okay, because it does not pass the vertical line test. Okay, right here both of these pass the vertical line test, as you can see. Okay, no matter where I am, it only crosses the graph one and only once. So this is how the vertical line test works. Okay, so right here, is this a function? Yes, the answer would be yes, because um, this also will pass the vertical line test. Okay, if I were to uh, use the vertical line, okay, whenever, okay, it does not go through the graph more than once. Okay, so this one passes the vertical line test. Yes, this is a function. Okay, that means for every input there is exactly one output. How about this one? It looks like it is a function until we get here, and you can see that right here. Okay, it does not pass the vertical line test because of these two right here. Okay, that means for this x value we have two different y value, so this one is not a function. Okay, how about this one? Okay, yes, this one is a function. Okay, even though it look like at this level that it does not pass the vertical line test, the fact that this is a hole, it means that there's nothing there. Okay, and this is a dot, means that there is something there. So that's a piecewise function that you are going to discover later on. Okay, so this one also is a function, okay, because it passes the vertical line test. Okay, so what this means is that, okay, at this point right here, okay, only the one that you have the data count, because the other one shows that there's nothing there. So it crosses only once there as well. Okay, so the only one that is not a function would be this one. Okay, it does not pass the vertical line test. Okay, so for this one, okay, and this one is a no. Okay, not a function. Okay, and the rest is yes, it is a function. This one also, yes, it is a function, represent a function. Okay, so that what basically a function is. Okay, so here again is the definition, and we just use the vertical line test to test some of the graph and identify which one are functions. Okay, let's start closing this app. Something that I want to mention before I end this lesson is that uh, a function is sometimes given a name. Okay, for example, these equations that represent functions, okay, can be given names. Okay, for example, y equal to x can be given the name f of x. Okay, f of x, remember this is read f of x equal to x. This is not multiplication. It just means that um, the, the function is defined in terms of the variable x. Okay. As a matter of fact, your f of x is can be replaced by y. F of x is exactly y if you are writing it as an equation. So don't confuse this with multiplication. It's not. Okay. It just means the function in terms of x. That means the input, okay, variable is x. Okay. So read it this way: f of x equal to x. Okay. Here are other example. Okay. Y equal 3x plus 7. Okay. We can give this function the name g of x equal 3x plus 7. Okay. They can give any name you want to a function. H of x, f of x, w of x, so forth. Okay, right here it's g of x equal 3x plus 7. That's how you read it. Again, this is not multiplication. It just means that the function g is in terms of x. Okay, the input x variable. Now, even though here is you can call your function also p of t. So the most popular variable that we use when it comes to function, okay, the name is f. Maybe because function start with f, okay, but it's not the only name. F is just the most popular one, okay. But you can call a function as you wish, okay, if you are the one naming it. But this one is called p of t, okay. That means the function p is written, okay, is defined in terms of uh, the variable t, okay, equal at plus 5. So instead of x here, we have t, and that's a possibility also, okay. Especially when you are talking about time, uh, we can use so this is how you read it, p of t equal at plus 5, okay. I found this summary somewhere that I believe would be useful to you. Okay, there are several vocabulary uh, referring to function that you'll be hearing more and more. Okay, for your input variable, okay, we have x and t that we use right here. So x and t, okay, are the input variable we use here, and uh, output you have y, okay, f of x, g of x, p of t. So those are your output values, okay. uh, the domain is the set of all your input variable, okay. When we talk about the domain of a function, we are talking about uh, the set of your input variables, okay. Okay. We'll cover some of these later on. So I just wanted to uh, domain element, okay, the x values or input, okay. The x values are also known as the independent variables, okay. Or the input is the same as the argument sometimes, okay. The output variable or um, range are the set of output variable. The image is basically an output value, okay. So you are going to see sometimes the y values are called the dependent variable, okay. So those are keywords that you need to be familiar with. And the relation, okay, is actually the function. So FGP, what I call the relationship. Okay, we'll stop here and we'll clarify some of these in class. Okay, and